Section 2.3 is really more of the same, still solving the system of equations using the Gauss-Jordan method, which is just a way of manipulating a matrix until it's in reduced row echelon form. So I'm going to show you an example of doing this by hand, and we saw this in section 2.2, so you know that you also can enter this in the calculator, but just to give you more examples to use as you study, I will show you one by hand. And I'm going to do an example where we have two variables and three equations. So we're used to seeing like three variables, then we'll have three equations. So I'm going to show you something a little different. Now here's an example of a system that has more equations than variables. So it could have a unique solution. So you just get one XY pair. It could have no solutions, or it could have many solutions. So to solve this, I'm going to set up an augmented matrix, just using the coefficients of these variables. I'm going to use our row operation to get this matrix in reduced row echelon. Reduced row echelon form, we are looking for 1 on the diagonal and zeros everywhere else. So I already have a 1, the 1, 1 spot, which is what I want. So next I'm going to focus on getting zeros the rest of the first column. So to get a 0 in this 2, 1 spot, I'm going to use row 1. So if I multiply row 1 by -3 and then add it to row 2, that would eliminate this 3 here. So the operation that I'm going to use, and I'm going to make it negative so that when I add them, I get 0. So I'm going to do -3 times row 1 and add it to row 2. Make that my new row 2. So I'm going to put off to the side here the calculations that I'm making. So the row 1, I'm multiplying every piece by -3. So it becomes -3, -9, -33. And then I'm going to add it to row 2. So this is row 2. I'm going to add the 2 together. And just like I wanted, this gives me 0. Here I get -13 and -39. All right, so this is my new row 2. So I'm going to rewrite my matrix. I'm replacing row 2 with what I just calculated, but that's the only change that I'm making here. So now let's see if we can get a 0 in this spot in row 3. So I could use row 1 again. This time I would need this to become a -2 so that when I add it to this 2, I get 0. So I'm going to multiply row 1 by -2 and then add it to row 3. So -1 times row, -2 times row 1. I'm going to add that to row 3, and that's going to become my new row 3. So -2 times row 1 would make this a -2, -6, -22. And I'm going to add that to row 3. So I got 0, -13, and -39. So this is my new row 3. So rewriting my matrix. So now my first column is 1, 0, and that's what I wanted. So now I'm going to move to the second column and focus on trying to get that where I have a 1. I want a 1 in this spot. So getting a 1 there, it looks like I could just divide this row by -13. Sometimes the concern with doing that is that you end up with fractions, but -39 is divisible by 13, so it should be fine here. Not that there's anything wrong with fractions, but sometimes they make the calculation a little more difficult. So I'm just going to take row 2 and I'm going to divide it by -13. And that's going to become my new row 2. Now, row 2 is 0, 1, -3, +3. So -13 divided by 13 is 1. -39 divided by 13, -13 is 3. All right, so now I have achieved getting the 1 in that spot. I'm going to put row 3 back on here. And now I need a 0 here. Let's start with that first. Let's see if we can get a 0 in this 1, 2 spot. So since I've got a 1 here, I can multiply this row by -3 and add it to that row. And I want to make sure that I keep this 1 here. So I want to make sure that doing that won't change this 1. And it won't because I have the 0 here, so when I multiply it by -3, it's still 0. I add it to 1, and that stays a 1, so it's not going to change that spot. If I multiply row 2 by -3, add it to row 1, and make that my new row 1. So in doing that, row 2 would become 0, -3, -9, and I'm going to add that to row 1. So row 2, this is row 1. Well, this is -3 times row 2, and this is row 1. Add them together, and I would get 1, 0, 2. So that is my new row 1. 1, 0, 2 in the first row. The other rows stay the same. Now, since in my system I only had x's and y's, and this tells me x, and this tells me y, I just need for the third row to zero out. If I get something on the bottom row that wouldn't be true, so maybe I get a 0 here and then I get some number right here, if they're not equal to each other, then this would not be true. And it would mean that my system is inconsistent and there's no solution. But here it looks like I can zero it out, and I actually could have done it from here when those two were the same. If I just subtracted them, that would have done it. Since I didn't do that, here I would have to multiply row 2 by 13 again and add it to row 3. Make that my new row 3. So then I would get 0, 13, 39, that's row 2. And then I'm not changing anything about row 3. I'm going to add them together, and that gives me 0 for the last row. Now my matrix is 1, 0, 2, 0, 1, 3, and 0, 0 on the bottom row. So putting my variables back in there, what this says is that x is equal to 2, y is equal to 3, and the last row says 0 equals 0, and as long as that's true, then it's fine. So like I said, if we end up with 0 and then a number or two numbers that are not equal to each other, that would tell you that there's no solution. But we got 0, which is true, so we just get this one solution to our system, right? So solving a system of equations using matrices by hand is a process, and it takes practice, but it is completely doable. So I wanted to make sure that you saw how to solve this without a calculator.